Figures 9.11 through 13, the order in which constructors and destructors are called. So far as we've introduced the concepts of class definitions, one of the key concepts we've discussed is that of the constructor, which is called when an object of a class is created, so that you can make sure that the object gets initialized at the time that it's created and is already in a consistent state for use by the program. Another key member function of a class is the destructor, and this is a member function that is guaranteed to get called when the object of the class goes out of scope or is physically deleted from memory when we're dealing with dynamic memory allocation. And basically it's a cleanup function. What you put inside the destructor is any code that needs to release resources that the object may have acquired. For example, if the constructor for a class acquires a file and allows you to then use the object to interact with the file, the destructor might be used to close that file. Or if the constructor for a class obtains dynamically allocated memory, the destructor would be used to return that dynamically allocated memory back to the system. In this example, it's a mechanical example to show you when constructors and destructors get called for different objects in a program. And in particular, we'll also show you the syntax of declaring and defining a destructor as well. So here we have a class called create and destroy, and we'll be creating objects of this class to show you when their constructors get called and when their destructors get called as well. In the private part of the class here, you can see that we have an integer called object ID and a string called message. We'll be using these as part of our output in the program so we can see which object is being created or destroyed at a given time. And we have just a constructor that receives an integer and a string to initialize those two pieces of data, and now for the first time a destructor. The destructor must start with the tilde character followed by the name of your class and an empty set of parentheses. You can only have one destructor per class, and it must receive no arguments. So the destructor is always going to look like line 14, except that you'll have whatever your class name is rather than create and destroy. Now, the implementation of this class is pretty straightforward. We have just the definitions of our constructor and our destructor, both of which are part of the create and destroy class's scope. In the case of the constructor, we receive the integer ID and the string message string, and we assign them to the corresponding data members. And then for demonstration purposes, we output the word object followed by the object ID number, followed by the string constructor runs, and then the message that's associated with that object. In the case of the destructor, again, it must be declared or defined with the tilde character followed by the name of your class and an empty set of parentheses. And in this program, if the object ID is either 1 or 6, we're going to also output a new line character. For all other objects, IDs will output just an empty string. And then separately, lines 25 and 26 are going to output the word object, the number of the object's ID number, the word's destructor runs, and then the object's message. So let's go ahead and take a look at our program, which is going to be invoking the constructors and destructors for this class. And before I actually look at the code, I'm going to run the program so that we can see the output as we walk our way through the source code. So let's take a look at the source code now. Of course, we include the header file for our class definition, otherwise we can't use the class. We have a function called create, which takes no arguments and returns nothing. And of course, this function is going to be used to create objects, as you'll see. And for the right before we get to main, we have a global object of class create and destroy that we're creating. The object's name is first, its ID number is 1, and the message string that we're placing into the object is global before main. Now, when you create a global object, it does not get its constructor call right at that moment because you have to get the program up and running first. So the compiler automatically sets up as the very first thing to happen inside of main that the constructor for the object first will get called. And that means before I even get to main function execution begins, I should see the constructor for class create and destroy display some information about this object called first. So if we stop there and take a look at our output window, we see that object 1's constructor runs and it's a global before main. Then we see the first output statement inside of main execute. So again, if you create any global objects, their constructors will get called as main begins executing and before any of the code in main executes. Now, the next thing we did is we created a couple of other create and destroy objects. At line 17, we have a local create and destroy object called second, initialized with the ID 2. Local automatic in main is its message. And then we created a static local variable as well, the create and destroy object called third, and its ID number is 3, and it's a local static in main. Now, remember, static local variables are created at the moment their declaration is encountered, and then they exist from that point until the program terminates. And that's going to affect, in this program, when the destructor will get called for this object. In general, destructors are called in the reverse order from which constructors are called. So normally, the destructor for the object called third would be called before the one for second. However, because this is a static local variable, this object actually lasts longer than the one called second, and therefore the order of the destructor calls will be a little bit different from what we would normally expect. Now, so let's stop there and take a look at our output window once again, and we can see the two objects, object numbers 2 and 3, with their constructors running, the local automatic in main and the local static in main. The next thing we do is call our function create, and inside of create we first output a heading that indicates that create function execution begins, so that's going to get us to this point in our output window. And in create we're going to build 3 objects, a create and destroy object called fifth, which is initialized with the number 5. You may say, why didn't we do 4? Basically, we numbered these objects vertically in the source code, so the object number 4 is actually created at the end of main after we call create, so we'll get back to that in a moment. So create and destroy fifth with the number 5, local automatic and create, a static local variable of type create and destroy called sixth, a local static and create, and then another local automatic variable called seventh is created. Now, as we hit the end of create, we're going to display that the create function execution ends, and at this point, the local automatic variables fifth and seventh will no longer exist. Their memory is going to be deallocated, and therefore their destructors will get called. And as I mentioned, destructors get called in the reverse order from the constructors. So because fifth was created before seventh, seventh will be destroyed before fifth. So let's take a look at our output window to see the constructor calls first of all. So you can see objects 5, 6, and 7 were created, and we have their messages being displayed. Then we see that the create function execution ends, and then we see object 7's destructor runs, followed by object 5's destructor. Again, these are happening in the reverse order from which those two objects were created in the first place. And notice that you don't see anything for the object 6, which was declared static in the function create. Remember, static local variables exist from the moment they are created until the program terminates. So this static variable will not get destroyed until the main function ends. When the program terminates, then the destructors for the remaining statically allocated objects will get called, and we'll see that in just a moment. So we return from the create function back to line 20, and then we move to the next line in the main function where we display main function execution resumes. So that gets us to this point in the program output. Then we create the object called fourth with the number 4 for its ID, the local automatic in main, and we can see that its constructor executes. Then we indicate that the main function execution ends, so that gives us this line of output here. And then when we hit return 0, that's going to terminate main and thus begin the process of terminating the program. Now, before the program can terminate, the destructors for any remaining objects need to be called. So let's look at main again, and we see we have a local automatic object called fourth, and a local automatic object called second that were defined inside of main. And again, their destructors will be called in the reverse order from which their constructors were called. So fourth will be destroyed first, and then second will be destroyed next. So if you look at the next two lines of output, you see that the object 4 got destroyed first and the object 2 got destroyed second, the reverse order from which they were constructed. Then we still have three objects left in our program. We have the global object first, the static local object third, and the static local object sixth. And those were created in the order first, followed by third, followed by sixth. So they should be destroyed in the reverse order, sixth, followed by third, followed by first. And if you take a look at the last three lines of output here, you can see that indeed object 6 was destroyed first out of those statically allocated objects. Global objects are considered to be statically allocated as well. Object 3 was next, and then the global object that was created before main is destroyed last. So again, in general, when you construct objects, the order in which they are constructed is going to be reversed to call the destructors, and the things that affect whether all objects are created in the reverse order from which they were constructed is whether or not some of those objects are statically allocated objects. Anything that's a static local variable is going to be destroyed at the end of the program's execution, but in the reverse order from which those statically allocated objects were created. And of course, the other key thing we looked at in this example is the syntax for creating a destructor. As we proceed into the C++ fundamentals Part 2, we'll get into our first dynamically allocated memory, at which point we'll actually build real destructors that have the purpose of deallocating memory that was associated with an object and allocated in the corresponding constructor.